Welcome to the inaugural Soils Network of Knowledge webinar, Drought in Your Soils. Your presenter is Graeme Schwenke from New South Wales DPI.
Okay, I better kick off. So drought in your soil. Thanks for inviting me to talk about this today. And when the next slide comes up, I'm sorry there's a little bit of a delay between when I click the button to get the next slide and when it actually appears. So you should have it now. This is the outline of what I'll be covering in the talk today. I'm looking at some of the physical effects, biological effects, chemical and nutritional effects of drought, and then what happens to soils after drought, and a little bit about recovery management. So I'll see how much of that I can squeeze in. So first of all, just talking a bit about the soil physical properties or how they're affected by drought. It does take a little bit to come through. Well, most of my experience in the northwest of the state here has dealt with cracking clays. Black, grey and brown clays can develop pretty big, deep, wide cracks during drought. Some people ask, are these big cracks the problem? Well, unless you drop your phone into them, no, they're actually a good thing. It's cracks of nature's way of tillage. So they'll help get rid of some of your compaction issues if you've got them. And generally speaking, their structure's probably about as good as it's ever likely going to be because this is a self-repairing soil. These high clay soils do have a large water holding capacity, but when they're very dry, such as in a drought, and the crop's basically done all it can to get as much water out of the profile, it'll take quite a bit of water to refill those soils up again for another crop, and even just to refill an air dry soil back up to the moisture potential where plants can actually withdraw some of that moisture. So that's cracking clays. Non-cracking loamy soils, the structure of these generally deteriorates during drought, and it's particularly bad if you don't have cover over the soil, and if your organic matter is low. These topsoils, some of them can become very dry and powdery. In this state they're very highly vulnerable to particularly wind erosion. Some of these soils can also set hard into a structureless mass as they're drying, and thereafter become very difficult or impossible to cultivate until their profile is re-wetted again. The soil strength increases rapidly as the soil dries, and seedlings really need to have been established before that strength becomes too high for root or shoot emergence. But mostly this hard setting behaviour is reversed when rains come again. But one of the problems with the hard set soil, of course, is you've got a very smooth surface, and that can increase runoff of rain when it does rain again. One of the things that you can do with those sorts of soils is it's not recommended to do sort of intensive tillage, but one option is ripping along contours to actually sort of make little rip lines along those contours, so that when the significant rains do come again after the drought, the soil surface will have some means of holding that water run across the surface, and that'll help improve the infiltration of water and even can reduce some of the wind erosion as well. So yeah, while tillage does further deplete organic matter, some tillage may be necessary to create that rough surface and to reduce the runoff. Of course, if you've got stubble, this next slide's showing some different levels of stubble, you've got some ground cover. But unfortunately with droughts, low crop yields tends to equal low stubble loads and often poor ground cover, and this can then lead to loss of topsoil. These pictures on the slide here indicate the sort of level of ground cover you get from different crop yields. So you can see you need reasonable amount of yield before you get 100% cover. And this is just for flattened wheat stubble. The ratings vary for other types of crop stubbles and whether they're standing or flattened. And the next slide's just got some tips, if you like, or more information about stubble. Absorbing rainfall energy, it reduces surface sealing, promotes infiltration and reduces runoff and erosion. So this is all basically things to have in place before a drought comes. So that's part of normal farming system plan. So basically, the more stubble you have, the better. If it's anchored into the soil, it's going to be more effective, and more effective if it's standing than flattened. And yeah, its direction across the direction of erosive agents such as water or wind makes it more or less effective. So it's a bit about the stubble, but yeah, a little bit more on that is that basically if you've lost that ground cover, and that can happen through either intensive cultivation or burning of stubble or removal of stubble as well for sale as hay. Once you've lost it, you're really opening up your soil to erosion, and the potential can be quite serious. A further indirect effect of having that stubble cover is that if you've got it, the water can infiltrate into the soil rather than ponding on the surface and then starting to run off when you do get rain. And that water infiltration is really important for the next crop, because you'll store that for the next crop rather than losing it down the drain. Let's see, another important, and perhaps one of the most important factors is when you're losing topsoil, you're losing organic matter as well, because your organic matter and a lot of the nutrients that are associated with that organic matter are really concentrated in the soil surface. As this next little graphic is showing, this is a typical profile of organic matter in the top 20 centimetres of some of the vertisols that I've worked with, the cracking clays. And as you can see, it's quite high at the surface and it drops away with depth, and that's even more the case with non-cracking swelling soils. But what can happen if you lose the top part of that topsoil, and the graphic here will show if you lose the top 5 centimetres, straight away you've had a pretty dramatic decline. And when you come back and sample it, you'll actually see 18% less organic carbon in the next soil test you do if that top 5 centimetres is washed away, and that's not unheard of. 5 centimetres is pretty bad. So that's a bit about soil physical properties. So next we're going to talk a little bit more about biological properties and how they're affected by drought. Number one is, well, basically, as with plants, all elements of soil biology are affected by prolonged dry periods, but unlike plants, most elements of native and naturalised soil biota have some type of resilience mechanism that allows them to, in some form, survive drought conditions. So for bacteria, they could take the place of bacteria going into a form of dormancy. They can form spores that will survive dry conditions, or the cells will dehydrate. It's also the case that the death of the bacteria is quite high as well, but there's survivors out there and they recolonise quite quickly afterwards. It's interesting that actually that fungi can actually generally remain active at even lower moisture contents than bacteria can, and as well they also produce these resting spores that will help them to recolonise after the drought, and other forms of the biota such as earthworms. For example, earthworms can actually burrow quite deep in the soil during hot, long dry periods, and that's been researched a little bit in the western part of the state here, but extensively around overseas areas. But earthworms can also sort of wrap themselves up into a sort of ball of mucus, and inside the soil form a little metabolic, it's like a hibernation, or estivation it's called. Of course there's other impacts. Enzymes in the soil, their activity declines in very dry conditions, and it's well known that a long fallow, which obviously you're going to get in a cropping situation, does reduce significantly the amount of arbuscular mycorrhizae, or AM fungi, and that can in the follow-up seasonally to pour phosphorus nutrition for those crops that are otherwise dependent on that mycorrhizae for their phosphorus supply. The next slide shows a graphic that just highlights the fact that as you go from wet to dry conditions, both plant activity and microbial activity do decline. But as you can see on the graphic, and I'm not sure if you can see the mouse there, the water potential of minus 1500 kilopascals, where you reach permanent wilting point for most crop plants, there's still up to 40% of the peak activity of the microbial community. So they do still continue to work at low moisture conditions, as we've seen. Fungi can actually operate down to minus 5 megapascals in terms of their activity. Another important point coming up on the next slide is that during a long extended fallow, as you get during a drought, basically the decomposition of soil organic matter will continue, because you do get small periods of light rainfall, and that's enough to wet the surface and spark a little bit of microbial activity on the decomposition organic matter. But basically, if there's no crop or pasture growing, there's going to be no new organic input, so organic matter levels do tend to decrease during that extended fallow. So moving on to some effects on chemical properties. One that's come up in the interweb quite a bit is effects on pH in soils. Very dry soil conditions can actually change pH, both make it more acidic or, in other cases, more alkaline. Often the case of soil pH becoming more acidic is due to when the dry conditions basically stranding soluble salts in the topsoil, and these soluble salts could come from inorganic fertilizer, so if they're not being used by the plants or being leached by rainfall down lower in the profile, they can result in a higher hydrogen and ion concentration, and therefore pH, and that can be measured as a greater acidity in the soil solution. If you're actually measuring your pHs in water, that'll be the case. If you're actually measuring in calcium chloride solution, you may not actually see that effect, because the calcium chloride solution has some soluble salts in there, obviously the calcium chloride, to actually mask those small changes, seasonal changes in pH. So it's an observed effect. It tends to be fairly small. It doesn't affect the it doesn't change the need for any liming of acid soils, so it doesn't make you need to change the amount of lime that you need to correct any acidity problems you may already have. It's also been noted by one of my colleagues, Mark Conyers, in Wagga Wagga, that some of the soils that he works with, their pH can actually become more alkaline in some of those soils, where he's noted that soils with more easily reducible manganese oxide. But in both cases, with this and the soil becoming more acidic, the trend tends to reverse when the rains reappear, so not a big problem. Now moving on to some effects on some of the nutrient elements, and the main nutrient element in most cases is nitrogen. And now in terms of nitrogen, in a dry year, your normal losses of nitrogen from the soil that you may experience through leaching or denitrification if it's really wet, or even ammonia volatilization, those losses don't tend to be very noticeable. Therefore, you've removed part of that part from the cycle. If you've got drought-affected crops, they're going to be removing less nitrogen from the soil. particularly from the surface soil if it's becoming very air dry. And if your plants aren't growing to their expected potential, which is most likely if it's a drought season, then some of those plants, particularly if the farmer decides that the crop's not going anywhere, will use it for stock feed instead, some of those can have still have quite high nitrate concentrations in them if the plants are cut when they're very young. So that's something to be wary of if those plants are going to be fed for livestock. And obviously you're going to be removing less. Test before feeding. Sorry, I'll go back one there before we jump to that. Yeah, it's important to note that not only are we losing less from those processes like leaching and denitrification, but you're removing less from the field through your harvest. Less grain or perhaps no grain. So it's greatly reduced. So you're actually going to, or you tend to have more nitrogen accumulated in the soil, and the next graphic will hopefully illustrate that. This is actually some data from one of our long-term cropping trial sites at Warrialda. Soil nitrate, as you can see in the graph here, this is the first line here is sampled at the end of 1993 after the previous crop, so there's very little nitrate left in the profile, so that's the usual situation. There's about 9 kilograms of nitrogen per hectare. But what happened in the following year, there was basically drought situation. We didn't get the crop in, but what happens is the nitrate does continue to form through small rainfall events that you do get during that season where we weren't able to have a crop. And you can see after a year later we've accumulated some nitrate in the profile, and some of that's progressively leached lower in the profile through what rains did fall. And the mineralisation of the organic matter does continue during the drought. And what happened by the following year, by the time it was ready to sow the next crop in May 1995, we actually had 170 kilograms of nitrogen per hectare at the end of that drought. So at the start of that crop we actually had quite a bit in that profile, whereas normally at that time of year after a normal crop we would only have about 60 to 70 kilograms of nitrate in that profile. If soils are really dry, in terms of the processes that form nitrogen, I've said the mineralisation continues. The first part of mineralisation is ammonification, which is conversion of the organic matter to ammonium. And that process does continue in drier soils. Then the next part, which converts the ammonium to nitrate. So you can actually get a small increase of ammonium nitrogen in your soil as well as nitrate. So the graph that I've got there is only showing nitrate, but there may also be an accumulation of ammonium there as well. Once the rains return, that ammonium is quickly then converted through to nitrate. So nitrogen. Next we've got phosphorus. Not as quite as an exciting story in phosphorus. Phosphorus, unlike nitrogen, phosphorus is immobile in the soil unless it's carried away by erosion. So unless you've got a high P-fixing soil, a lot of the phosphorus that was available this year, a lot of that should remain fairly similar. Obviously, if you've got water-limited plants, your uptake is going to be reduced, particularly from air-dry surface soils where the phosphorus is concentrated. If you are removing the crop residues for straw, you're going to be removing a bit more phosphorus than you would normally in grain, but not a great deal. The actual fixation by P during long dry periods can actually either increase, which has been noted for calcareous soils, soils high in calcium carbonate or lime, due to precipitation reactions with the calcium in or near fertiliser granules, or the fixation can actually decrease in more acidic soil. So it can go a little bit either way. In the case of the calcareous soils, it was found that the fluid phosphorus fertilisers did not tend to have the same reaction as the normal solid fertilisers. So that may be a better option on those soils. That's phosphorus. Potassium. Potassium is also immobile in most soils except sandy soils. It can leach in sandy soils. What's basically happening with your potassium is you're going to reduce the amount of potassium leached from the crop residues back into the soil without the normal fallow rains. So you're basically calling a halt to the recycling process. Potassium is interesting in that you tend to find potassium deficiency occurring more in crops in drought situations. But it's a vicious cycle because not only are droughted plants more susceptible to potassium deficiency in soils that are otherwise adequate in NP, but maybe a bit low, but potassium deficiency in plants can actually make plants more susceptible to drought as well. So it's a bit of a vicious cycle because potassium is important for regulating leaf moisture through the opening and closing of stomata, and that process is slowed when the potassium is deficient in the plant. Potassium deficiency is not all that common in most New South Wales wheat growing areas, but can occur in tablelands and coastal areas used for crops and pastures. It's interesting to note that in the US, information is that the best responses they get to potassium fertiliser tend to occur in very dry years. So that's sort of backing up that link between potassium and drought survival. And one last point with potassium is that if the crop's failed, or even if the crop's been harvested but the farmers decided to take the residues off in baling, then you'll actually be removing quite a lot more of the potassium than you would normally remove just in the grain. So if the potassium status is a bit iffy, then you need to take that into account, that you take a lot more off. So that's some of the drought effects. Let's look at what happens in drought recovery. So obviously we've touched on erosion a fair bit at the start. So erosion due to drought-breaking rain can be pretty severe, and a fact from I think it was the Soil Conservation Service a few years back that most of the total soil loss you get in a long-term cycle comes in that drought-breaking rains where you've got those bare paddocks. And just another reminder that if you're losing that topsoil, then you're really depleting your organic matter, which is a major source of your nitrogen and phosphorus, and a lot of the potassium ends up in the surface through that recycling normally as well. What happens when a soil's re-wetted is that you often get a flush of mineralisation. So the bacteria that have been actually dormant in the soil suddenly come to life with a bit of water, and they go crazy feeding on a lot of the decomposing other microbes that have been killed by the drought, and this flush effect can last from a few days up to sort of a week. So that tends to release more nitrogen particularly. But yeah, again, another bit of caution when the drought breaks, your nitrate uptake by plants can be high because obviously we've touched on that before. A lot of nitrogen can be present in droughted soils. So once the plants start growing again, if they're if it's been a drought-affected crop or perhaps a pasture, especially in the first week of rain, hungry animals allowed free access to these plants, you can have disastrous losses due to nitrate poisoning in some cases, and also prussic acid can form in some plant species. which is also toxic to livestock as well. It's a pretty potent, rapidly acting poison that stops the body cells receiving oxygen. Another point with regards to drought recovery effects, particularly for this part of the world where you've got high clay soils, as I mentioned before, you need a fair bit of rain to bring an air-dried soil back up above permanent wilting point before any plants in the soil or being planted can actually access that. If you've got cracking soils, obviously some of the first rains will actually begin refilling the profile from the bottom of those cracks until the cracks close up. And it's interesting also, or important to note, that these clay subsoils, not just in heavy clay soils, but often in duplex soils, some of the clay subsoils are very slow to refill. They have a slow infiltration rate. So just because you've had a fair bit of rain, don't just necessarily assume that the profile's full up straight away. It's good that you need to actually probe the soil and see where the actual wetting depth has got to, particularly in some of the heavy sodic clays where the infiltration can basically stop, and some of the subsoils can actually remain dry even though the surface can be waterlogged. And of course, if you do get waterlogging, that may lead to denitrification. So a lot of that nitrate that was sitting there, if you get really heavy, intense rains that waterlog your soil and make it anaerobic, then a sizable amount of that nitrate can be lost as gases back to the atmosphere. So just a little bit now about recovery management. So soil testing is important after a drought because we need to really get a handle on what's actually there in terms of N, P and K levels in the soil. As we've seen, particularly N can be quite a bit different from what you'd normally expect. So you might be able to reduce the fertiliser that's going to be required. And it's similar with phosphorus. The actual amount that you need to put on for the coming crop may need to be reduced a little bit, and as I've said, some of those short-term drought effects can actually be a little bit misleading if you're considering as part of a long-term strategy. So sort of treat it as a one-off year if that's the case. Try and test as close as you can to the crop, and close as practicably to when the crop's are going to be grown, so that any further changes if there's large rainfall events don't sort of affect your planting too much. Just a little tip for people using anhydrous ammonia is just a reminder that you've really got to get that moisture content right. So if it's soil's still a bit too dry and you don't get proper closure, then a lot of that gas can escape from the slot. And also if it's too wet as well, the slot also probably won't close up properly. And another tip there about the phosphorus fertiliser, that requirement's likely to be reduced if that previous crop has failed. Another couple of important points. Obviously, we've talked a lot about erosion, and it's important to re-establish ground cover fairly quickly, particularly on bare paddocks, to prevent erosion. But in the same breath, it's important that you need to control regrowth of failed crops and weeds after breaking rains. So otherwise, some of that precious water that's occurred after the drought could be used up by the last crop having another spurt of growth where it's not going to give you any benefit in terms of cash. And the same with weeds. So it's important to get on top of weeds there. And not only for water as well, but as in terms of disease break, getting rid of that disease host bridge between crops can be quite important. As I said previously, it's very important to check your store water situation, what it actually is and not what you think it might be based on the rains, particularly if you've had a fair bit of runoff. And don't sort of be too quick to jump in and plant another crop if that subsoil hasn't properly refilled. And yeah, soil-borne and stubble-borne diseases can be actually more severe after drought, particularly if there's failed crops there or undecomposed stubble. Normally with crown rot you're depending on a lot of that stubble to decompose during the fallow season or during a previous break crop, and if that doesn't happen, then a fair bit of that crown rot inoculum can be carried over for the next season. And in other diseases such as take-all, where you have bacterial antagonists working against the disease, those bacterial numbers can decline quite a bit during the drought. So that inoculum can survive and affect crops worse than what you would otherwise think. So that's around about all the facts and figures that I've managed to drum up about drought. A lot of these have come from the department's info sheets, which are all available on the DPI website. If you go to the DPI Home Agriculture and do a search and find drought and emergency section, there's actually quite a lot of information, fact sheets like this one, soil management following drought. It's just coming up now, which Abby, our host for today, has penned. Soil nitrate after drought. It's got some of those information and figures that I showed. Soil phosphorus after drought was another good one. And the last few facts that I gave were from the crop diseases after drought fact sheet. A lot of these are done in the last decade during the last drought. And yeah, just a final reminder, I suppose, that one of the most important things, lack of rain qualifies you for farm assistance, but lack of topsoil may not qualify you as a farm anymore. So try and keep it in place if you can.